In this video, we're going to discuss the average rate of change over specific intervals of quadratic functions. You remember from linear functions, a line had the same rate of change over the entire line. The slope was the same for the entire line. A quadratic function, however, a parabola, is not like that. The rate of change from here to here is obviously different than the rate of change from here to here, or from here to here. The one that's now in green is obviously much steeper than the one that's now in light blue. So when you find the rate of change over specific intervals of quadratic functions, you will have a different slope for different parts of the function. Let's look at an example. Let's say we have the function y is equal to 3x squared plus 2x minus 1. And we're going to find the rate of change over two intervals. We'll find the rate of change first from x is equal to -1 until x is equal to 0, and then we'll find the rate of change from x is equal to 2 until x is equal to 3. So to find the rate of change, we need to have the change in y values over the change in x values. And we have our two x values. We have -1 and 0. But we want to find our corresponding y values. To find the corresponding y values, we're going to plug in the x's that we have into the original equation to solve for the corresponding y values. So for x is equal to -1, the y is going to be equal to 3 times -1 squared plus 2 times -1 minus 1. The easiest way to do this is just punch the whole string of numbers into the calculator. 3 times -1 squared plus 2 times -1 minus 1. Minus 1. And then enter. So y is equal to 0. So our first y value is y is equal to 0. So our 2 points are going to be -1, 0, and 0, when we plug in x is equal to 0, what will be our y value? 3 times 0 squared plus 2 times 0 minus 1. And this is easy to just do in your head because 0 squared is just 0, 3 times 0 is 0, 2 times 0 is just 0, so we're left with y is equal to -1. So here are our 2 points, -1, 0, and 0, -1. Now we're going to do delta y over delta x using these 2 points. Delta y over delta x, which means the change in y values over the change in x values. The change in y values are 0 minus -1, then the change in x values is -1 minus 0. 0 minus -1 is just 0 plus 1, which is 1. -1 minus 0 is -1. So the slope over this interval is -1. That's the slope from -1 until 0. Let's see what the slope is going to be from 2 to 3. We need to find delta y over delta x. We have our two x values, but we need to find our y values. So we're going to plug in. Y is equal to, when we have x being 2, 3 times 2 squared plus 2 times 2 minus 1. Let's just type the whole thing into the calculator. 3 times 2 squared plus 2 times 2 minus 1. Minus 1. Enter. That's 15. So our first point is 2, 15. And our other point is y is equal to, when we plug in as x is equal to 3, 3 times 3 squared plus 2 times 3 minus 1. And let's just plug this in. 3 times 3 squared plus 2 times 3 minus 1. Enter. That's 32. So our second point is 3, 32. And let's see what the rate of change is. What's the slope over this interval? We're going to do delta y over delta x. The change in y values is 15 minus 32. Change in x values is 2 minus 3. 15 minus 32 is -17. Over 2 minus 3 is -1. So the slope over this interval is 17. So you could see from this, from what we just solved, that the slope on some parts of this parabola is going to be negative, and the slope on some parts is going to be positive, and that's what we expected, because part of the parabola has a negative slope, what's now shown in red, and part of it has a positive slope, what's now shown in green. So we assumed, we knew that part of it would be a negative slope and part of it would be positive slope. And we also assumed that part of it would be steeper. This part of the slope with the 17 is much steeper than the part of the slope with the negative 1. And we assumed that also because over here, what's now shown in light blue, is obviously much steeper than over here, which is now shown in purple.